Today on Insight, Professor Ian Bonnell, an astrophysicist within the School of Physics and Astronomy at St Andrews, talks to us about what qualities he needed to become a successful academic, his favourite sport at the Winter Olympics, and the one snack food he couldn't live without. Enjoy listening. You're listening to Insight, the University of St Andrews Student Physics Society's podcast. I'm your host, Samuel Avery. Join us as we journey into the lives of St Andrews academics, discovering their passions, inspirations, and motivations. Today on Insight, we're interviewing Professor Ian Bonnell, an astrophysicist at the School of Physics and Astronomy. Thanks for joining us.
Good day, thank you.
And first question, what are your positions here at St Andrews?
Okay, so I've been in St Andrews now for 25 years. I arrived as a lecturer a number of years ago, and then about 10 years ago, I think I was promoted up to professor. And so my positions at currently, I am an advisor of studies for the junior honors year. That's the third level of studies here. And I am also a deputy director of teaching. And I have been in the past also an exam officer.
So quite a range of activities.
Quite a range of activities. Good fun.
Excellent. And what path led you to your position here then? Was it the
in St.
standard? Was it undergrad, postdoc?
Yeah, so I did.
Any detours?
Not too many. I was a student in Canada, in Quebec, and I went to Cambridge as a postdoc. I was there. I came over. My wife agreed that we should spend a couple of years in Europe, so we came over for what was supposedly 2 years. I ended up getting a fellowship there and ended up staying 7 years in Cambridge and deciding that we liked it quite a bit. Had an opportunity. We came up to St Andrews one time with a Scottish student in Cambridge, and she showed us around. And we quite liked St Andrews and decided that would be a nice place to come to. And I got very lucky with jobs at the time and was able to get a job here at some point. So.
And you've stuck around ever since?
And I haven't left since then, yes, no.
So you're also quite an established astrophysicist.
Mm-hmm.
You're a fellow of the Royal Society of Edinburgh.
Correct, yes.
And what led you to follow the research that you've done over your career then? What is it that you're researching?
Why is it I research in astrophysics? Well, I guess it was a bit of a change. As an undergraduate, I had spent some summers working in a nuclear physics lab, and I thought I was going to end up doing nuclear physics. And I think I woke up one morning in the middle of summer saying, this is not what I want to do. And so I decided to change into astrophysics. To do so, I had to quickly apply for a PhD position at a different university than I had intended to go to. So I was going to go to McGill, and I had changed University of Montreal, and also had to change language and do it in French rather than English, which made it a little bit more of a challenge, but it was good. So maybe I'm not answering the question properly. So you mean about the actual research area?
Yeah.
So the research area in the star formation, I guess it's part that it uses the physics that we like doing, these gravitational physics involve fluid dynamics, and part that you can explore the origins of where things come from and that. And I think the two together are the motivation factor behind it. It was also lucky, I think, that for anyone when you start doing an area, working on your research career, an area which is more open to actually develop. And I was lucky at the time when I came in to do my PhD and afterwards, that the area was changing and there was a lot more capability of doing things. I use a lot of numerical simulations to follow the gravitational fluid dynamics. And at the time, the computing resources were becoming available to do a lot more. And so that was an opportunity, I think, so the two together, the motivation and the opportunity, went well together.
So it's that combination.
Mm-hmm.
And you mentioned there that you had to switch to learning in French.
Yes. Well, for Quebec, most people are functionally bilingual. And in
Were
fact,
you the same?
Mostly. And I had done a lot of French in grade school and secondary school. But I had been a few years studying only in English. But in Montreal, the population is fairly mixed. So half the people I was studying undergraduate with were Francophone, studying English. And then I went to study in French, and I was one of a few Anglophones studying there. not quite as many.
Interesting. And have you still got it? French and English?
Just about.
Any other languages?
No. Well, from that you can do a little bit of Spanish and Italian, enough to get a meal and a glass of wine.
All you need then.
The important things.
So do you have a favourite thing about your field of research, star formation?
The favourite thing? Well, the favourite, I guess what I like doing best is to setting up a problem and then trying to, so it uses numerical simulations. And so it's kind of like although it's called theoretical astrophysics, it's really almost experimental because you're designing the equations and seeing how the fluid and gravity works. But then you have a lot of data to actually sort through and to try to decode what is actually going on in the physics of the process. So that's the fun bit, when you actually get to look at it and take it apart. And
so it's the pattern finding within the
finding
numbers.
the patterns, finding what kind of physics you think is going on, coming up with a conjecture and then going back and testing it. And you come up with a conjecture, I think this is what's happening there. And then going and you've got the data sets. And it's lovely because you've got data sets which are 3 dimensions, velocities, and time. And you can go back and take it all apart and make links through there. And that is quite fun to be able to do.
Like a giant jigsaw.
It's a giant jigsaw, but 3-dimensional and it moves.
Excellent. And do you have a piece of work that you've done that's made you proudest?
There is, I guess, in terms of research work, there's probably one thing I'm best known for having done, which is a theory called competitive accretion, where stars will compete for a mass reservoir, and the ones that happen to be in a gravitational potential near the center are able to accrete more of the gas, are kind of aided by everyone else, which kind of feeds the mass into them, but they aren't able to accrete that mass. So it's sort of like an economic model gone mad, where the rich get richer and the poor stay very poor. So that's the piece that I most, I guess, would be attributed to my name from that. Although in some ways we did a piece of work at one point which was more analytical, looking at how, as a byproduct of that kind of action, you can get really dense systems where stars can actually collide together. And that was a lot of fun doing it because it was quite different from other things we had.
So the class system of the stars and those
Yes.
bumper carts of the stars.
Exactly. That kind of process, which are quite different than you would normally think about in terms of how stars form. Though actually the thing I would feel most proudest of, the career-wise, is the people you've worked with who have gone on to doing other things as well. And so the students, the postgrads who have gone off to doing whole research careers themselves. And that's good fun.
Well, that's quite lovely as well, yeah. So do you think that if humans were to develop interstellar travel, studying other stars would be a focus? So if you were able to travel to another star system, do you think that studying that star would be of interest? Because currently we use a lot of models based on our sun.
Yes, well, I mean, we're studying a lot of other stars in terms of exoplanets and that, because whether life can exist around another star depends a lot on that star. And there's lots of clues in other stars in terms of what they're made out of and how much angular momentum they have, how much they spin, in terms of how they formed, but also in terms of their environment, whether there'll be planets around them, somewhere to actually find life at some point. Or if humans, I guess, were ever going to go visit and live on a different planet, you'd have to do a lot of studying first to see which ones are most likely or have somewhere you can live on.
And following on from that, have you ever considered the Fermi paradox, that with all these planets and stars that we shouldn't be alone, according to probability? It
would seem unlikely that we'd be alone. It doesn't seem that long to me that we first discovered extrasolar planets. And so there was a point before that where you could say, well, maybe there's something very, very strange. But especially since now we know that extrasolar planets are very common, it seems very unlikely, you think, that in the whole galaxy that there's no other place, or in the whole universe, even worse, that there would be life somewhere else.
Excellent. Have you committed enough to buying a T-shirt? We believe.
Not quite that.
So I've got a bit of a challenge for you. So could you try and explain, to the best of your ability, star formation in 1 minute? You have 1 minute to explain what you think are the highlights.
Of star formation. Okay. So stars form...
Time starts now.
Stars form in giant complexes called molecular clouds, which are very dense bits of our galaxy. If we had them on the Earth, they'd be the best vacuum we could create. So our best vacuums in this building are denser than these dense bits of our galaxy called molecular clouds. They have lots of supersonic motions, turbulence in them, which generate lots of structure through shocks. At some point, gravity will take over on some scale, either of an individual star, but most likely actually in forming a larger scale of a whole stellar cluster. And that starts making the whole region collapse. Subregions can fragment, form individual objects. And inside there, different stars can actually start accreting different amounts of gas, and they get a myriad of different masses out of it. So not like us, we're almost all the same mass. Stars go from 100 times less than the mass of the sun up to 100 times more than the mass of the sun.
1.
I'll stop there.
That seems quite comprehensive, though. You think that was a good shot?
Perhaps it could be done with a little bit more. There's no ending point, though. Because the other bit of star formation says, where does it go into planet formation? And that would be another minute.
Next interview.
Good.
So you've mentioned that you do a lot of work with advising students,
yes,
and younger physicists and astrophysicists, and people have come through your research groups as well. So when you're doing your advising, do you tend to see students who are like set in their choices and their degree path from the first moment, or do students come in with a lot of uncertainty?
Most students, at least by the time they're in junior honors, I would say probably 3/4 of them are quite certain what they want to do. But there's always a good fraction who have lots of different opportunities, lots of different possibilities still open to them, which is quite a challenge. There are a few students I recall very well who, coming into third year, had a whole bunch of spreadsheets of possibilities they would like to do. And the goal was then to keep as many options as possible open for that year. And a couple of them decided later on, I think at the end of their junior honors year, much beyond when they're supposed to have decided, to what their actual degree path would be, and made it work. So those are good challenges.
And it's quite exciting when it works.
It is. Well, it works it will work for the students. And it's quite nice to see them having that flexibility and really making decisions which are right for them. And they may not be the original decision, they can change. So a couple of them who would decide to go into theoretical physics, then changed to astrophysics. A couple came in astrophysics, went to theoretical physics, back and forth. And having that, making sure they're doing something that's right for them is good. It's important.
Do you think there's one degree path that people tend to change away from more than the others?
No, I think there's a lot of changing back and forth.
So fairly even between.
Fairly even.
Between
possibly
theory,
into straight experimental physics is most people come into, and then may change into theoretical physics. If you're going to do astrophysics, most of them come in doing astrophysics as an idea.
Mm-hmm. Okay.
Yeah. And sometimes going to joint degrees, which have different challenges.
What do you think is the best way for students to map out future modules and their degree? Do you think it's the spreadsheet approach?
Having some awareness where they want to go. So in I guess for joint degree students where they're forced to think through their maths modules early on, makes them contemplate what they need to do. In physics, we're more prescriptive, so most routes are generally open under each degree program. But having an idea what they would like to do and what later modules they would like to tackle makes it the best mode forward to make sure they have everything they need.
So awareness of the options.
Awareness of what's going forward, yes. And possibly thinking what they may want to do afterwards. Although the degree programs here are, I think, enough of the fundamentals that it really doesn't matter. You could go from a theoretical physics degree and do a PhD in something quite different, experimental astrophysics, back and forth. I think those options are still mostly open for students.
So it's a good springboard. Almost.
Yes, I think they're all good springboards.
Are there any qualities that you notice developing in students over the course of their degree? Do you think that there's anything that stands out as, a lot of students go from being less confident to more confident?
Definitely they've become more confident along the way, majority. They also, at some point, everybody comes face to face with added challenges of the degree program, and how they overcome those added challenges is good to see, I think. And they're difficult because students coming into this program are all very, very strong. And so at some point, they all come across a difficult moment in their degree program, and how they overcome that and become stronger for that is very good.
Lovely. And is there anything that you wish you could see more of in students? more self-belief?
That's very interesting. I don't know if there's confidence. Yeah, confidence and self-belief, because I think a lot more students these days, at least I'm aware of a lot more students these days having confidence issues or being stressed by the program, but stressed by studying. I think that's part of modern life. I think that more people are stressed than was apparent when I was a student. But I'm probably seeing a different side of it as well.
Maybe a tinge of nostalgia in the way.
No, I think we were not always aware of it as going through the program. You don't see that. But now you see there's a lot of students have issues with stress and that of the program. I would encourage more people to actually go make use of student services even before they get stressed. That would be my advice to anyone.
And is there a worse part of being a student advisor?
A worse part? No, I don't think so. I think there are some difficult parts when people have when there's particular difficulties that students are going through. But that's not. It's difficult, but it's not a worse part, because it's good to be able to possibly do something positive in those situations.
Okay, that's quite enlightening. Uplifting. You've also interacted a lot with student representatives. Mm-hmm. So how many class reps and school presidents do you think that you've maybe worked with over the years?
Well, I think I can probably name all the school presidents since they were first as a position. It hasn't been that long that we've had school presidents. So I've been involved with ever since they were first a part of the system.
And when was that?
Sometime, I would think 7 or 8 years ago now. It's hard to be remember exactly how long, but the years tend to drift into each other after a while. I've been a junior honors advisor for 7 years, I think, as well. So I would have dealt with all the reps since then, and probably some of them beforehand when I was a sub-honors advisor or module coordinator.
And do you think it's important to have these roles?
Oh yeah, no, it's excellent. The class reps play a fantastic role in terms of helping interaction between the staff and the student body, and that making sure things are running well and getting good feedback back and forth. And it's I think we're very lucky that students here take an active role in their education. It's not something that happens to them, it's something they do, they participate in, which is what education's about. So I remember when I was the first as an undergraduate, and I came in and my advisor told me, we're not here to teach you facts, we're here to teach you how to teach yourself, which is what education should be really about. And so, and having active students participating in that is what is necessary for that process.
It's a good thing to have then, definitely. And as a student advisor and a lecturer, you must interact with a lot of students within the school. But what's your reaction if you meet them out with the school? If you see them around town, do you ignore them, or do you do a brief greeting, or do you do like a nod from across the street?
I think you'd greet them as you normally would. Modular the fact that when you see people out of context, your brain doesn't always pick up directly who they are, the people, and then recognize them as easily.
So you generally see them and then go, who was that, for the next hour?
I think that happens for, yes, a lot of people, especially I live in a small village and there's lots of people you know, and you're not always sure how you know them. You know them just by being in the street. So with the students going through, unfortunately my memory is not as good, that 70 students coming through every year. After a few years, it's hard to keep track.
I'm sure they don't begrudge you for it.
No, I think they all get used to the fact that our memories aren't as good as they should be.
So moving on to some more general questions. You mentioned that you grew up in Canada. Mm-hmm. Do you ever find that patriotism has played a part in your academic career?
Probably not Canadian patriotism anyway, I would think. But I left Canada along 25 years ago. So my whole academic career mostly has been in the UK. The one, I think, most interesting anecdote was, so we'd be always considered as being British scientists, even if their origin is outside the United Kingdom. And I remember one time there was a press release released by some American competitors, I would say. And they were saying they were putting the kibosh on a British theory, which was kind of amusing. Turned out I don't think they were quite right in any case. But the amusing bit was that a lot of people then emailed me support, but the comment that came back a couple of times was that, and the thing that riled them the most was that the people they were being labeled as British were both colonials. So it was a Kiwi and myself who were the two who were being mislabeled as being the British on that hand. So it's that kind of, I guess, level of patriotism may come into it, but overall it's not.
Doesn't feature too
much
the
in
academic
science.
scene.
No.
And do you identify with any previous scientists and maybe feel proud for legacies they've left behind? Do you think, Einstein and I, we have, the same personality traits? Or
Same personality traits? Certainly not.
Well, or identify in any way.
No, I mean, I think growing up, I remember a time when I found a textbook by I didn't know, but esteemed British astronomer named Fred Hoyle. And the building I was working with in Cambridge was named after him. And he did a lot in astrophysics, so he wrote some very good textbooks, which were quite inspiring, I found, as a pre-university student, I think. I first started reading them. So that was always interesting. I met him later on in his life, but it wasn't quite the same as reading his textbook. I interacted with quite a few people in Cambridge who were very good role models in terms of what they're doing. And there was an esteemed astrophysicist who passed away sadly last week, but he was Donald Lyndon Bell by name. He even is a movie star, and there's a movie called Starmen you can watch, showing recreating a trip they had taken in their youth. But the thing I remember most about him was that at the end of his career, he was saying that he thought he had been proved right 3 times over his career, which he thought for a theoretician it was not bad.
3 times, that's the goal.
3 times over all his creations.
So would you describe Fred Hoyle as a science idol, or do you have another one who you might
A science idol, but as in any idol, when you see them differently as you
perceive them
as you first perceived them, you discover they're much more interesting, I suppose, but less one-dimensional, less of an idol than you would have seen as a kid.
They have other personality traits.
Oh yes. Which is good.
Is there anyone that you think deserves more recognition for work that they've done?
Probably most scientists deserve more recognition than for the work they've done.
Everyone.
Yes, I don't know if I would say I can name anyone specifically who I think probably deserves more than.
But
yeah. No,
maybe as a community, society should cut us some slack.
Yes, I think it's quite interesting, and it's a shame that they don't get to see more, I guess, people, the scientists going around. So just general, see them as they are.
Do you think exposure would help with that?
Yeah. So again, this movie I watched with my daughter just 2 weeks ago, Starmen. It was quite interesting to see that, and to see someone I knew as being portrayed. Well, it was him on the film, so it was interesting to see how he was being seen by the public that way.
Are there any qualities that you think have helped you in life most? Intelligence, persistence, charisma, for example?
Persistence, stubbornness, and resilience, I would think, are the most important ones. Intelligence, I think everyone has, especially if you're studying sciences and that. But the persistence, resilience, curiosity, not want to giving up a problem, are the skill sets, or the attributes, core things that really help. Yes, not being put off by open-ended problems that don't seem to have necessarily an answer.
And do you think those are kind of inherent traits, or do you think you've trained them up over a lifetime?
I think they're probably mostly inherent traits. I can't think of anything I've done to train up. Resilience you can definitely train, or I think we're probably getting better as a society to be able to train it up. It used to be something which people just had or didn't have. But curiosity. And curiosity is something that you probably get trained at as a kid, you're from your youth, your parents and everything else. And the idea to go out there and find out the information yourself.
Is there any qualities that you think have changed since your student days? You're more laid back, or
no? I would think
more
I'm
stressed. Maybe?
Probably less laid back than student
less
days.
Laid back.
Yes, unfortunately, we'd like to think we're all more laid back than we were, but I think the opposite is probably true. Life does tend to give you more things to get stressed about.
Oh.
But perspective, on the other hand, you get a better perspective, and so when things do stress, they're never as big.
So the good comes with the
Yes.
bad.
Yeah.
So by the time this interview's out, it'll be around the time of the Winter Olympics. Do you watch the Winter or Summer Olympics at all?
Definitely have been watching the Winter Olympics. So being Canadian as an origin, probably my closest I get to being patriotic is by the Winter Olympics or ice hockey as being the two things. So definitely would watch the Winter Olympics quite a bit.
And is that a favourite sport?
Ice hockey would be a favourite sport
Do you have an
to
athlete
watch.
who you love out there?
Probably the athletes I used to watch was a kid. Again, having your youthful, it's hard to ever replace that completely. Would have been long since retired. I think as a kid, probably Guy Lafleur was probably the main one at the time in the 70s.
And were you about to say that although ice hockey is your favourite to watch, you have another sport that you like to do?
I think and winter sport these days in Scotland is not quite the same because there's not as much winter as we get. But yes, ice skating in general would be quite fun. Would be a good, common, popular sport. Although around Scotland we tend to do things more like kayaking, which is we can do in the sea. Can't do that in Canada in the winter very easily.
No, I imagine not.
No.
Are there any other sports and hobbies then? Ice skating and kayaking?
Hill walking.
Hill walking.
Hill walking would be the thing that would take me out most weekends. Scotland's very lovely, and we're very lucky to live in Scotland. So coming from Canada, if I want to go to see some mountains, I have to get in my car and basically drive for 2 days to see the Rockies, which are beautiful, wonderful mountains. But in Scotland, we have things which are relatively nearby, 2-3 hours you can drive. And so there's lots of places to go hill walking just for a day.
So it's nice to be able to
is.
go out on a day trip.
Yep.
And out of the Olympic sports, are there any that you would want to be good at? Do you ever wish you could be the best at bobsleighing? Or
Not bobsleighing, no. I think it would be speed skating would be the sport that would be the most appealing to be good at, I think. Yeah.
Are there any other sort of competitions that you like to participate in or watch?
Or watch.
Like Great British Bake Off or
No, certainly no.
Crufts dog shows maybe?
No, I don't think there's anything like that. No, not that competitive in that way.
Fair enough. So we're going to move on to the quickfire round, so you can answer these a bit quicker, but feel free to take time to explain
I might be
your
able
answers.
to, we'll see.
So the first one is possibly a bit difficult to answer quickly. Do you have a favourite music genre and song?
And song. Well, I like a variety of different music genres. I get accused of listening to too much jazz by the person I drive in every day who takes a strong dislike to jazz. But probably early 70s rock music would be the most common music I would listen to.
Good choice, good choice.
It is a good choice. I think most people like it, yeah.
And is there one song that stands out? A favourite at the moment or a favourite over time?
A favourite, probably, if I had to pick out one song, it would be probably something called Cajun Moon by an artist called J.J. Cale, who I guess a 70s guitarist from somewhere in Tennessee or something.
Cajun moon, why does your power lie as you move across the southern sky? You took my babe way too soon. What have you done? Cajun moon, someday, babe, when you want your man.
Okay. Do you have a favourite non-academic book?
A favourite non-academic book? I have, yes, probably quite a few favourite non-academic books. depending on when in my life, I guess, it would have been.
What do you want to list some of
Now, okay, so I guess Crime and Punishment would be the book that probably had the most effect on me as a 16 or 17-year-old when I read it, as changing your outlook on life. Then later on, things like Aldous Huxley's Eyeless in Gaza, or Island, later on. And recently, I would say the book that I've read in the past 10 years that had the biggest effect is probably, what is it called? The Wind-Up Bird Chronicle by a Japanese author named Murakami.
I can't say I've heard of it.
Famous for Kafka on the Shore, was a novel that came out not too long ago, which made him quite popular. But the Wind-Up Bird Chronicle, it's where the main character starts off by cooking pasta, and there's bits of where the main character spends some time down a well to try to get a unique perspective on life.
It does sound interesting.
It's very strange, surreal, and has quite a bit of jazz discussion in there as well.
So that helps.
That helps.
Would you rather read a poem or a play?
A play, I think. Mostly a play. And it depends on the poem what it would be. If it was something maybe John Donne or something, a poem. But you can read a play and you can get more of a storyline out of it without. And
do you have a favourite board game? Or card game?
Or card game or a dense game or something. I would suppose the game I'd most often be playing would be something like Quirkle, which is a domino type game of pieces that you would play down. It's not quite a board game. That or I can't even remember the other one. But mostly because it's favorite in that the whole family can play it without anyone getting upset.
I don't believe it. It doesn't sound realistic.
Well, there you go.
Do you prefer your holidays to be hot or cold?
Not too hot.
Temperate.
Yeah, so for example, I like a trip to the Mediterranean once a year, but we try to go when it's not so warm, mid-20s, late 20s. Certainly not over 30 or so.
That's where you draw the line.
Yes, whereas Christmas holidays, we went back to Montreal and it was 25 below zero. I'm not sure I was chosen as 25 below zero.
Plus or minus 30, that's kind of the range.
Mid-20s would be perfect for most things.
Okay. And do you prefer active holidays or relaxing holidays? Do you want to sit at home all day and read a book, or do you want to get out and do stuff?
I like a relaxing holiday, but I think I'd be accused of not ever having been allowed anyone to have one. So yes, getting out and doing things most often. Yes, some physical activity or some adventure.
That sounds good. And is there one snack food that you couldn't live without?
That I couldn't live without. I tried to live without dark plain chocolate digestives, but I haven't been very successful.
It's not going well.
It's not going well. No, they're a constant.
Do you prefer cooking or baking?
Cooking.
Do you have a favorite dish that you like to rustle up?
No, but probably something with pasta of some sort.
And are you a morning or an afternoon person?
Until most of my life, I would never have been accused or even being close to being accused of being a morning person. But recently, I'm more of a morning person than I used to be. So traditionally, I would say definitely not a morning person. But with life, in the past 5 or so years, I even prefer having 9 o'clock lectures.
Wild.
Yes.
I don't think many people say they prefer 9 o'clock lectures.
And I certainly never did as a student.
Do you think your students, do you see any of them enjoying them?
They enjoyed their 9 o'clock lectures more than I did.
Oh, wow. So, this is the finishing question, so you can spend some more time over it. So, you do a lot as a staff member for helping to support students going through the school, and it's something that you've done yourself in your previous degrees. But what do you think is the most important way for students to support other students within the school?
Well, I think it's also one of the things that works quite well in physics, that there is a lot of student support. And so being free to ask each other's questions about a topic and seeking each other's support is very good. Directly with the people in the same class, so they can actually work together, but also then asking people in different years and then getting that kind of support across the years. at least in part, just so you can see people who have survived through what you've going through at the moment. You've seen people who've gone through it, look back and yes, that was fine. And, so that kind of support area is very important. So having as much communication in a class, in a cohort, but across all the cohorts, I think is very helpful.
So it's that communication between students and
Yes.
seeing others having gone through it and knowing that you can too.
Yes, yeah, seeing that it's, because every time you're going through anything you're going through seems very crucial and the challenge seems more acute. But knowing that it's actually there is a pathway through it and that they will be successful can help. So.
There's a light at the end of the tunnel.
Exactly. Yeah.
Okay, well, thank you very much, Professor Ian Bonnell, for joining us today.
No, thank you for having me.
Hope you've enjoyed yourself.
I have. Thank you. It was good
Excellent.
fun.
You've been listening to Insight, the University of St Andrews Student Physics Society's podcast. I was your host, Samuel Lavery. Thanks to all the wonderful academics of St Andrews. Join us in the future as we learn more of the people making our education. This podcast was produced by myself and our publicity officer, Connor McBride. To find out more about the Physics Society and what we do, please find us on Facebook or Google St Andrews Physics Society for our website. Goodbye!